yes, of course. We've been interested in understanding how ionizing radiation interacts with matter for a very long time. And ionizing radiation is, all around us, right? It comes from the sun, it's in the form of UV, in the form of X-rays, and everybody is familiar with it. And we also know that ionizing radiation causes damage to many things. When you go out into outer space, things are damaged by cosmic rays. When you go into your get an X-ray, you know that these may be damaging as well. You know that UV comes in and it damages your skin and so on and so forth. But we're really interested in trying to understand this at its most elementary and fastest level, at the time scale and length scale of electrons and atoms. And so for this, you really need properties where you can follow things on these time and length scales. And that is actually what the XFELs and instruments like SCS are particularly well attuned to. I mean, you can really only study things like this with such sophisticated instruments. Well, there are two things that are particularly special about SCS. The first thing that's particularly special is there's this super fancy DSSC detector, which I think probably anyone who's been around the European XFEL has heard about this for quite some time. Super sophisticated because it could take pictures at a very fast frame rate. But then a new system was devised to be able to do shot-to-shot normalization of transmission through a sample and also transmission outside the sample, all simultaneously shot to shot. This allows one to get X-ray absorption spectra very, very precisely with this good normalization. And therefore, you can do this also after an ionizing event happens. So an ionizing event happens and you take this snapshot, and you can do this at a fairly high repetition rate. And so this is I would say super special. It's the only place, it's a unique capability in the world that I only heard about when I heard Loïc Le Guyadet give a seminar on one of these worldwide XFEL club seminars. And so it was very cool. And oh, this is something we could really use. And so then we made a proposal, and we were fortunate enough to get beam time, and we're very happy to come. Yeah, it sounds like a very esoteric thing. I'm talking about ionizing radiation, et cetera, but really when the ionizing process happens, the electron finds its way into the conduction band. It's kind of delocalized, and until it becomes localized somewhere, you don't have a chemical reaction that happens. So you want to know how long that takes, where it actually is localized, and so on and so forth. And the same thing happens, when the electron leaves, it leaves a hole behind, and that hole is also a very reactive species. So you have these two things that you'd like to track in time and space, and that's what we can do with the SCS.